to determine the distance between 2 points on a Cartesian coordinate plane, we first are going to plot the points. So we have 2, -4. So 1, 2, 1, 2, 3, 4. Plot the point here. And then we have -3, 3. So 1, 2, 3, 1, 2, 3. Now, this is what the vectors would look like. And determine the distance between these points and their polar coordinates. All right. Well, let's first find out what the magnitude is of each of the vectors. Let's call point 2, -4, let's call that vector A. And point -3, 3, let's call this vector B. If you dot a vector with itself, you get the magnitude of the vector. So we can do A dot A is equal to, let's write this vector out in coordinate form first. So A is equal to 2 in the I-caret direction minus 4 in the j-caret direction. And what we do is we write this in the two-dimensional Pythagorean theorem form. So this is going to be 2 squared plus -4 squared. Take the square root of that. That's 4 plus 16. That ends up being the square root of 20, which is going to be 4.74. And that's just 4.74 units. We don't really have a dimension. Well, it's in meters. The units are in meters, so 4.74 meters. All right, now if we take B and dot it with itself, take the scalar product of B. First, write this in the correct form. -3 I-caret plus 3 j-caret. That's going to be equal to -3 squared plus 3 squared. Take the square root. And 9 plus 9, square root of 18, and that's going to be 4.24 meters. All right, these are the magnitudes of the vectors, but they are not the directions or the distance between them. So this is going to be A dot A. And we'll write that this is 4.74, and we'll write that this is 4.24. Now, what we need to do is find the distance from there to there. If you have two sides of a triangle and the angle between, you can use the law of cosines to find out what that resultant distance is, or what that, we could just call that, we'll call that little a. All right, we'll call that capital A. Now, in order to get those angles, we're going to look at vector A here. So this is the axis, the y-axis coming down, and you had to go over 2 and down -4. So the magnitude is actually just 4. We draw that here. We're looking for that angle. We're going to call that theta, and this is 90 degrees. All right, that's the negative y-axis, which goes down -4. If this is 2, then that's 2. And we've got a side and a side, so we use tangent theta is equal to opposite over. We're going to use the magnitude of the hypotenuse, which is just of the adjacent side, which is just going to be 4. So that's tangent theta is equal to 1/2. Theta is going to be equal to the inverse tangent of 0.5. And so we're going to have an angle equal to, all right, turn the calculator on, make sure it is in degrees. Inverse tangent of 0.5 is 26.56 degrees. All right, now that gives us what this small angle is right here. This angle here is 90. So 90 plus 26.56 plus whatever this angle is here is equal to that large angle. So we're going to take B. Vector B goes that way in the second quadrant. it goes to the left. The components go to the left. -3, I'm just going to write 3, and then +3 up, because we're only really interested in the magnitude, not the negative signs. And we're looking for this angle here. We're going to call that theta also. Tangent theta is equal to adjacent over hypotenuse, or sorry, opposite over adjacent. So opposite side over adjacent side. And tangent theta is equal to 1. Theta is equal to the inverse tangent of 1. And that's 45 degrees. If we add 45 degrees to this, we get the magnitude of the size of the large angle. So 45 plus 90 plus 26.56 gives us 161.56. We're going to redraw this here. And we'll say this is 161.56. The magnitude of vector B was 4.24. So we'll write that here, 4.24. And the other vector was 4.74. All right. Now, the length of that side is here. We're going to call that side A. We'll call this capital A. We'll call that side B. We'll call that side C. This will be angle B, but that's not necessary. We'll call that angle C, but that's not necessary either. Plugging this into the law of cosines, A squared is going to be equal to B squared plus C squared minus 2BC times the cosine of angle A. We have B, we have C, we have angle A. We're going to take the square root of that. So A is going to be equal to the square root of 4.74 squared plus 4.24 squared minus 2 times 4.74 times 4.24 times the cosine of 161.56. And all that is under the square root. I'm going to break this up into parts and just say that 4.74 squared and plus 4.24 squared is equal to 40.44. And that's minus, I'm going to type in cosine, 161.56 is equal to negative 0.94 and some other numbers, times 4.24 enter, times 4.74 enter, times 2 enter. And that gives you negative 38. That's a negative sign there, so it's plus 38.13139. Don't really need to keep everything, but A is equal to that. Plus 40.44 is 78.57. And I'm just going to keep it all in the calculator, second square root, second answer. And that gives us 8.86. So A is 8.86, and that's in meters. Is it not stopping?
It won't stop.
I think that's what it did the last time.
Quit pressing it over and over. You're probably just starting and
Yeah,
stopping.
'cause you kept shaking it the whole entire time.
No, it
I
didn't.
was looking at it and it was like...
Yeah,
like
one thing you can
she
do
turned around
is
to look
just
at Grace and it was like on
do
the
that.